All right, relative frequency 5F. So the relative frequency is calculated when an experiment is performed. It is the estimation of that probability of the event based on the experiment. Okay, so before we go any further, let's just think about something for a second. Let's say I flipped a coin and I did it 100 times and I had heads and tails. Now, if I asked you before today what the probability of flipping tails on a coin, you would say that it's 1 in 2. And if I flipped it 100 times, you'd expect, according to probability, 50 of them to be heads and 50 of them to be tails. The idea is with relative frequency, we base it off the experiment. Now let's say I did this experiment. I flipped the coin 100 times in total and I got 30 heads and 70 tails, which is, the idea. We aren't in a perfect world where we actually are going to get 50 and 50. However, this is probably a little bit far apart than what we were expecting. So now all we're saying is, well, the relative frequency, it's just a fraction of it occurring. So we got 30 out of 100 and 70 out of 100, which again, simplify always, 3 out of 10 and 7 out of 10. And that's it. That is the relative frequency. Now, usually you'll see relative frequency written as a decimal or percentage also, rather than just fractions. So get used to seeing, 3 out of 10 is 0.3, 7 out of 10 is 0.7, or 30% and 70%. Any of those are fine for relative frequency. So keep that in mind. And if you're not great with your decimals, fractions, percentages, you can use your calculator. All right, so now let's come back up here. So the relative frequency, we know now it's the frequency of that data value over the total number that there was made. And the last little extra piece, it's not too important, but simulation. A simulation is just a model representing an experiment. So technically that little red table I have over here is a simulation of my experiment. So the first activity, I rolled a dice 120 times, and these were the answers I got. Now, out of curiosity, if we know a dice has 6 sides, and if I wrote it 120 times, the expected frequency would be 20, 20, 20, 20, 20, 20, 20, which would give 120, right? Because each side of a dice is meant to be the same probability as getting it any other side. Anyway, back to relative frequency. Let's go. I want you to write all of these as a decimal for this activity. So it's just a matter of, and in my HSC, if I had to fill something like this in, I would show them my working and then put that in your calculator and turn it into a decimal. Okay, so again, they could ask you to have your answer written as a fraction, a percentage, or a decimal, so be prepared for any of them. All right, this one's not going to be a very nice decimal. All right, let's scrap the idea of the decimal. Generally, if they ask a decimal, it's going to be because it's a nice decimal. Let's leave these as fractions then. So I'm going to get 1 in 6. So the idea is you take your frequency and divide it by the total. All right, I'm going to pause the video and finish off these. Otherwise, it'd be a good idea for you to pause the video and give them a go as well. All right, and there I get my answers. Now the idea is, if you plugged each one of those fractions into your calculator and plus them all together, you will get an answer of 1. Okay, so a total of 1. All right, I want you to have a go at the exercise. That's really all that's to it today. So 5F, questions 1, 3, 4, 10, 13, 15, 16, every letter. Let's see how you go with those.